Welcome to our talk on aided nonverbal communication through physical expressive objects. I am Stephanie Valencia, a PhD student at the HCI Institute at Carnegie Mellon University, and my co-authors are Mark Steidl, Michael Rivera, Cynthia Bennett, Jeffrey Bigham, and Henny Admoni. In this work, we co-designed a physical expressive object with our co-author Mark and his family. Mark is a disability rights advocate and augmented communicator. Mark's augmentative and alternative communication device, or AAC device, generates speech and supports his verbal communication. He composes messages on his device using a head switch. His AAC device is located on a mount attached to his wheelchair. Augmentative and alternative communication, or AAC, encompasses methods that can augment or replace our speech and writing. Some AAC methods are unaided by technology, like our facial expressions and body language. Aided AAC methods include tools someone can use in addition to their body, such as speech-generating devices like Mark's device, or communication boards with pictures. These systems do not currently support augmentations that use motion for nonverbal communication. Motion can help create nonverbal gestures in space that help manage turn-taking, attention, and execute actions that increase social agency. Through prior work, we identified motion-based AAC as a viable and underexplored modality and presented the concept of socially assistive sidekicks as expressive objects that could support augmented communicators in achieving a specific goal. We built on this prior work to carry out an extended exploration to design a sidekick that will support Mark's specific conversational goals. Mark had been a participant in a past study and had expressed interest in exploring a physical expressive sidekick that would allow him to better capture his communication partner's attention when needed and without interrupting the ongoing conversation. In our paper, we describe our process of discovering design opportunities for a sidekick for Mark, defining design priorities, developing prototypes, and testing the device in context. For the purpose of this talk, I will focus on sharing our resulting design and some lessons we learned when testing the sidekick. Please see our paper for more details on the design process and our reflection on carrying out remote co-design activities over an extended period of time. After many conversational brainstorming sessions, exchanging prototypes via video and images, and working together, we came up with this final design. The device is made of 3D printed parts and actuated by 2 microservo motors. One motor is used to move the base of the device, and the other motor moves an arm attached to the base. The time it takes Mark to compose a message can vary between a couple of seconds to up to minutes, and therefore he often asks for more time to compose a message to remind partners to wait. This inspired our design of a sidekick that moved an arm to call for attention and to resemble a timer. We have open sourced the 3D designs, software, and electronic schematics at github.com/sv²/AAC-sidekick. The sidekick attaches to Mark's wheelchair mount next to his AAC device and is a bright color red. The sidekick's arm also has the word typing on it. We designed different motions for the sidekick and chose 3 main motions to test. Each motion was controlled with a head switch and different press durations to enable different motion selections. The timer motion moves the arm of the sidekick as a second hand on a clock by moving left to right in a range of 180 degrees. We also had a wave motion to call for attention that moved the arm in a smaller angle range to simulate waving. Finally, we also had a reset motion that would bring back the sidekick to a home position. We delivered the sidekick to Mark to test at home. We used digital diary entries where Mark took notes on interactions where he used his sidekick. Due to the COVID-19 pandemic, most of the interactions Mark had were online meetings with different groups of partners, some very close to him like old friends and some new communication partners also unfamiliar with AAC. We learned that the sidekick had the potential to make it easier for Mark to communicate specific things, such as "I'm typing," "hold on a minute" while the sidekick was moving, or "I'm ready to participate" once the sidekick stopped moving. There were some differences among close partners and new partners. People familiar with AAC understood the psychic's purpose right away. Friends, previous assistants of Mark, and friends who also used AAC to communicate got it right away. We also learned that experienced communication partners really did not need the psychic to communicate with Mark, as they know how to read Mark's body language and they know to patiently wait. Nonetheless, having a physical and visually salient device made Mark's communication intent much clearer, especially for conversation partners who do not know where to place their attentional focus. For online interactions with large groups of unfamiliar partners, the psychic needed to be introduced. Communicating online required people to have their attention on Mark's video feed for the psychic to be effective, and new partners needed a way to know where to place their attention. The psychic was originally designed for face-to-face interactions, but it was interesting to reflect on the limitations of this approach for online meetings. Please see our discussion for more details. As a case study, this project demonstrates how motion can support AAC interactions and conversations. We also learned lessons on how to scaffold co-design activities to collaborate as a team and envision and develop a new technology. As we think about future work in this area, we recognize the need for these systems to be better integrated with AAC devices. We need AAC development tools that can allow users and developers to build their custom motions, test with their preferred access input methods, and design their own interactions. Custom-made sidekicks that move in physical space as a form of aided nonverbal AAC can provide augmented communicators with an additional expressive output to manage conversation dynamics. We argue that motion-based AAC achieved through expressive objects is a promising new communication modality to continue exploring. For more information, please see our paper, Aided Nonverbal Communication Through Physical Expressive Objects. You can also contact me on Twitter at SVALEVAL or my email svalencia@cmu.edu. Thank you so much for your attention.